Alright everybody, so I'm here to talk to you about dot products. Dot products are one of the two ways that we can multiply vectors, and the reason we're using dot products right now is because the definition of work equals F dot R or S or X or whatever you want to use for your displacement vector times the cosine of theta, where theta is the angle between F and R. So that right there is theta. Okay, and dot products are useful because dot products yield a scalar solution. There's another way to multiply vectors which yields a vector solution, and that's called a cross product, but we're not going to talk about that until we have to because those are a little trickier. So when you look at dot products, there's 5 sort of situations you can have, and that's one is where A and B are parallel. And when A and B are parallel, the dot product is just equal to the product because the cosine of 0 is 1, and in this case theta between these two angles would be 0. Okay, the next one is if the angle between A and B is less than 90, so theta would be less than 90. In this case, A dot B is going to be greater than 0. If A and B are separated by a 90-degree angle, then A dot B equals 0 because the cosine of 90 is 0. And then after this, we have greater than 90. Okay, and if that's A and that's B, okay, in this case A dot B will be less than 0, again because of the cosine. And then if you have anti-parallel vectors, so if A and B have theta between them equal to 180 degrees, then A dot B is going to be equal to negative AB. Alright, so now that we got that covered, let's talk about the mathematical definition of the dot product, how it works out. So we start with our two vectors A and B, and we put them in component form because just like when we add vectors, using components is way easier than using resultants because it's just easier. So if we take A and B and we expand this product out into the components, it's going to look like this. AX, which is the x component of A in the I direction, plus AY, which is the y component of A in the j direction, multiplied by B's components, so BXI plus BYJ. Okay, now if we FOIL this out, we're going to get this big pile of letters that looks like AX times BX, and they're both in the I direction, so we have two I's. So we multiply I times I, and then we add the middle term, which is going to be AX BY plus AY BX, throw in some parentheses. Now, in this case, since we have AX and BY, we have I's and J's. So we have I dot J with that one. And these two should technically have an I, or a dot between the I's. Alright, and then we add the final bits, which are the J components of each together. So it's going to be AYJ times BYJ. Alright, now remember, I dot I means these two things are parallel. So the cosine of two things that are parallel is 1 because the angle between them is 0. So in this case, that just yields AX BX, and then this becomes 1. So we just let it go. And to that we add nothing here because I dot J, the angle between them is 90, which is, and then if you take the cosine of 90, that's 0, so this whole term drops out. And then J and J again are parallel, so the final bit is just AY, BY, which yields something interesting about the definition of a dot product. A dot product is just the sum of the products of the vector components.